In this video, we're going to interpret a linear regression equation. The data below approximates NASA's data on the change in Antarctica's ice mass measured in gigatons relative to 2002, shown by the blue dots, and a linear regression equation shown by the red line. Note, a metric ton is approximately 2,200 pounds, so an American ton is 2,000 pounds, so a metric ton is a little bit bigger. And then a gigaton, giga stands for billion, so a gigaton is 1 billion metric tons. So here's our graph. So let's note some important features. First, we have years since 2002 for our horizontal axis. So notice we start at 0. So 0 represents 2002, 2004, 2006, 2008, etc. So in general, we're doing this relative to 2002, but we don't want to start way out at 2002 on this axis. So we define this variable this way so we can start at 0. Okay. The vertical axis is ice mass in gigatons relative to 2002. Okay. So this tells us the relative ice mass in whatever year since 2002. Now, as stated up here, the blue dots are actual data points. Okay, so here's a data point for somewhere in 2007, and relative to 2002, we were down 500 gigatons of Antarctic ice mass. Okay, and this red line represents our linear regression equation. Now, there's more information in the media lesson packet on how this is developed, but basically the idea is statisticians found a way. We have all of these data points, okay? They're not exactly on a line, okay? You might even look at that and say it doesn't look like a line, but we might say this is an elliptical cloud. That's how I was taught to think of it, okay? And all these values, although they're not on the line, there's definitely a trend. This is going downwards. So what this equation does, since we don't have an equation for all of these bunch of dots, this equation best approximates this data, okay, by basically finds the minimum sum of squared distances of all these points. It finds a line that does that, which turns out to be what we say is the best way to approximate the data. Okay, so it can give us a general idea, and this is a very simple formula from all of this data. Okay, let's go to the questions. So, based on the regression line, which is the red line, as the number of years since 2002 increases, the amount of ice in Antarctica blank. Okay, so we want to see a trend as the number of years since 2002 increases. So if we start at 0 and we move to the left, what does the line do? Well, we'll start here and notice the line is going downwards. So that means the amount of ice is decreasing. The next question asks, how are the number of years since 2002 and the change in the amount of ice in Antarctica correlated? Well, we talk about correlation in terms of positively correlated and negatively correlated. So positively correlated means if the horizontal axis, as it increases, if the vertical values were going up, so if we had something like this, it's positively correlated. Here, clearly, because it's going downwards and decreasing, we can say these two variables are negatively correlated. So you could think of we're moving down in a negative direction is associated with decreasing. So negatively correlated. Next question. The slope of the regression equation is approximately negative 127. Interpret the slope by completing the sentence below. So let's think about what this means. So going back to these two variables, the slope measures a comparison between the vertical value and the horizontal value. Okay, so right up here, just where there's a little room, it's actually a ratio of how the ice mass changes in gigatons. I'm just going to put giga for short here. Okay, over how the years are changing since 2002. Okay. Now, what we like to do is think of this as kind of what we call a unit rate. If we think of the year since 2002 as changing by 1, so let's put 1 year, then this negative 127, which we don't write over 1 since it's an integer, but we could think of that as how the ice mass is changing in gigatons. So negative 127 gigatons per 1 year since 2002. Okay, so remember the value tells you, the slope tells you how the vertical variable changes with respect to 1 unit of the horizontal variable. Okay, so let's put this in a sentence as well, what's increasing by 1? Years, or the years since 2002. So as the years since 2002 increases by 1, the blank, well, that's going to be the ice mass, and I'm noticing they have gigatons here, so we won't have to write that. The ice mass, and we could write in Antarctica, but there's not enough room. The ice mass decreases by, since this says decreases, we don't need to include the negative. That's included in the word. So we're just going to write decreases by 127 gigatons. Okay, so as time increases by 1, so every new year, we're losing an ice mass of 127 gigatons in Antarctica. Let's look at the next slide. So part D says, the regression equation approximates the change in the amount of ice since 2002 in Antarctica by the following variables and formula. Okay, so we already found a value of the line, the slope, which we just interpreted. And there's another value that we need to make the equation of the line. So let's see what the variables mean. Okay, so capital C, so we usually use letter that associate what we're looking at. So C for change. So capital C represents the change in the amount of ice in Antarctica since 2002. Okay, and T represents the number of years since 2002. And this is our formula that relates the number of years since 2002. If we put in any number of years, we can compute this expression and it will give us the corresponding change in the amount of ice. So let's continue to read. So use this equation to approximate the change in the amount of ice in Antarctica in the year 2018 by completing the sentence below. Okay, so notice we are given a year. So we're given a time value. Well, actually, let's call this a year. We're going to have to convert it to a t value. And we're asked to approximate the change in the amount of Antarctica's ice. So this is what we need to find. Okay, so typically in these types of questions, they give you one variable and ask you for another. A reverse of this, they could say, when is the change going to be 500 billion gigatons? And then you'd find the time. Here they're saying, we're giving you a time, found the amount of ice that the regression equation approximates. So we need our t value. So we know the year is 2018, but that is not our t value because remember t measures the years since 2002. And to find that value, basically we just have to subtract to find the difference. And we get that 2018 is 16 years after 2002. Okay, now we're going to replace t with 16 to find the change in the amount of ice. So let's want a different color. So the change in the amount of ice, so every year since 2002, we're going to lose 127 gigatons of ice. It's 16 years since 2002. And now we add 34. And let's just talk a second about this adding 34. So 34 represents the amount of ice when the time equals 0. So 0 years since 2002. And it makes sense that at that time, the change since 2002 in 2002 should be 0. Okay, and notice this is 34, which isn't 0. So this regression line, to really get the slope the best we can get it, sometimes we make a compromise and we let this value is going to be a little bit different from 0. Okay, and that's okay, because what we're really concerned about is we want to get the slope to correspond better. Okay, so this line says in 2002 we were up 34 gigatons since 2002, but we just use that because this equation fits the rest of the values really well. Okay, so now let's compute this on the calculator. Okay, so I think that's a negative button, but I never use it. Here's what I'm going to do. I'm going to do 127 times 16. So that's negative 2032. And if I add 34 to that, okay, since this is negative and positive, your calculator may have a negative button. I just don't know how that works. We want to find the difference between these two values. Notice that it would increase 2032 by 34, so this is going to be negative 1998. But basically, we'll just take this difference. There's 1998, and since the bigger number is negative, we have negative 1998. Okay, so the regression equation estimates that in the year 2018, the change in the amount of ice since the year 2002 will be negative 1,998 gigatons. So we could also interpret that we are losing 1,998 gigatons according to this model. Okay, does this mean that that's exactly what we've lost? No. Okay, so if we looked at 16, here are some of the values. Okay, so they're not going to match that exactly. Okay, some of them are close, but this model gives us a general idea.